Hi everyone. In this video, we are going to look into binomial distribution and Poisson distribution. How we going to use this binomial distribution and Poisson distribution for calculation of probability. In our previous video, there we discussed about Bernoulli probability and binomial probability, and there we have learnt about that Bernoulli probability is used for a single trial or a single event where that event where the event must have the two outcomes like success or failure, head or tail, germination or no germination, tall plant or short plant, like that. Two outcomes for a trial must be there, and it is applicable to only when one trial or one event is present. So whereas the binomial probability, this binomial probability is used when multiple trials or when multiple events are there, and each event must have the two probabilities, two outcomes such as a head and tail, like that. And but the probability of each outcome must be same in all the trials. So that means when there is a possibility that 50% is 50% is head and 50% is tail in first trial, so that must be there in the second trial also, like that. Okay, so next one is the Poisson distribution or Poisson probability and binomial probability. Now we are going to see how these two are different. So binomial probability, so multiple trials must be there and each trial must have the two probabilities. Then we use binomial probability to calculate the probability of uh, the outcomes. For example, when 10 trials are there, so what is the probability of 8 successes in 10 trials? So like that. For example, when we flip a coin for 10 times, what is the probability of 8 heads to come in 10 trials, or 7 heads to come in 10 trials, like that. We use binomial probability. So whereas the Poisson distribution, so this Poisson distribution is completely different. Here there is no fixed that means no what I can say, so there is no fixed trials like the 10 trials or 20 trials. There is no fixed trials, but this Poisson distribution, there we calculate the probability at a given time or at a given place, like that. For example, how many mutations are possible in nucleotides, that is one type. Or how many mutations possible in a particular nucleotide, that is we can calculate, but here no fixed trials. So when we use this Poisson distribution, for example, okay, we can calculate the probability like, no, suppose here we calculate the lambda is the average of the average probability. For example, we calculate, for example, suppose 10 lakhs nucleotides are there. So what is the probability of one mutation in that 10 lakhs nucleotides? So that is how we use the Poisson distribution. So binomial distribution or probability, there we calculate out of 1 lakh nucleotides, what is the probability for the, at least, what is the probability for 8 nucleotides or 7 nucleotides or 10 nucleotides to be mutated in that particular DNA. So there we use the binomial distribution. And the Poisson distribution, there are no fixed trials. And here also, for every for every event, there are two outcomes in a Poisson distribution. Also there is another distribution that is called the normal distribution. So and the normal distribution is used for the continuous data. For normal distribution probability is for continuous data, whereas this binomial distribution or a Poisson distribution or even Bernoulli distribution, all these are used for the discrete data. For example, like read counts, for example mutations. So these are not continuous data, whereas normal distribution probability, there like no weights or the heights of students. So such continuous data, for such continuous data we use the normal distribution probability. Normal distribution probability, there we don't calculate the probability for a exact value. For example, there we calculate for a range. Suppose what is the probability of height of students between 150 to 155, such a range of data or interval data, we calculate the probability. So in binomial probability or Poisson distribution probability, or in even Bernoulli's distribution probability, there we these three all are used to calculate the probability for the not continuous data. It is there for the discrete data. Thank you so much.